Okay, so welcome back. Now we're going to talk about the coefficient of variation. And so what the coefficient of variation is you take the standard deviation and you divide by either your sample mean or your population mean, depending on whether you're working with samples or means. So it's the same formula in either case. And what it does is it allows you to compare the standard deviations when you have different units of measure. We're going to look at an example here in a second. So it's basically giving you like standard deviation as a percentage of the total population size. So again, you take the population standard deviation or the sample standard deviation, you divide by the mean, and then you multiply by 100 because you're doing a percentage sort of calculation. The symbol for this is CVAR, for coefficient of variation. So if you read example 6, it says that the mean number of sales of cars over a 3-month period is 87, and the standard deviation is 5. Okay, so that they're selling cars. It looks like the mean number of sales is 87 for the salesman, but the standard deviation is 5. So some, might have sold 92, some might have sold 82. Anyways, the mean of the commissions is $5,225, and the standard deviation is 773. So we want to compare these two variations. So to start off for sales, you take CVAR, which is S divided by X bar, that's the sample mean. So that's the sample standard deviation divided by the sample mean, multiplied by 100. And so in this case, you would get, well, what do we get here? 5 divided by 87 times 100 is about 5.7%. Okay. And then to calculate the commissions, you take 773 divided by the standard deviation, or sorry, the mean, which was 5,225, and we multiply by 100, and you get 14.8%. So comparing those two numbers, the commissions coefficient of variation is larger than the sales coefficient of variation, which means that the commissions are more variable than the sales. So if you were working for this company, you might be a little upset because it's like, even though your sales are closer together, some people are making larger commissions. So that's just an idea. Okay, and then there's one last thing we want to mention, and it's called the range rule of thumb. It gives you an approximate for the standard deviation. It's a very rough estimate. It's like if you had to do a back of a envelope sort of calculation, you could just take the range of your data and then divide by 4. And again, this is not terribly accurate. If you have the time, you should be calculating the standard deviation. But if you just want a really rough estimate that you can do in your head, or maybe just like to double check your answer, you can take the range and divide by 4, and that should be approximately equal to the standard deviation. Karen, you taking the next slide?
Yes.
All right.
Okay, so next we're going to talk about Chebyshev's theorem. So this is a theorem that says that the proportion of values from a data set that fall within K standard deviations of the mean will be at least a certain amount. So his theorem basically gives us like a lower bound on the amount of values that fall within a certain amount of standard deviations from the mean. Okay, and his theorem specifically says that lower boundary, or that amount, is 1 minus 1 over K squared. Okay, where K is going to be some whole number larger than 1. So let's just kind of explore a little bit how this is going to work out for some different K values. So for example, let's say that K was 2. So we were trying to find the proportion of values that fall within 2 standard deviations of the mean. So what we would want to do is plug 2 in for K. So we would have 1 minus 1 over 2 squared, and then just simplify that out. So 1 minus 1/4 comes out to be 3/4. So what his theorem is telling us then is that at least 3/4, or 75% of all data values, will fall within 2 standard deviations of the mean. Now, if you want to figure out what that range actually is, then what you do is you take the mean and you're going to subtract 2 standard deviations. That's going to give you the lower value. And then to get the upper value, you're going to take the mean and add 2 standard deviations. Okay, and that'll tell you like what the lower value is and what the upper value is. Okay, so that's when k is 2. What about when k is 3?
So you're
So,
going to take 1 minus
yeah,
1 minus 1 over 3 squared. So you get 1 minus 1/9. Well, that's 8/9, which is about 88.89.
yeah, very good. So that tells us that when k is 3, at least 8/9 or 88.9% of all data values will fall within 3 standard deviations of the mean. And then to figure out what that range actually is, you're going to take, your mean again, and now you're going to subtract 3 standard deviations to get the lower value, and then add 3 standard deviations to get the upper value. So you can see that this value here will change depending on what your k is. Now, k is not always going to be, just 2 or 3. It can be other values. Connect math, though, tends to stick with just k being 2, 3, 4, or 5. Those are the only ones I've ever seen in all the hundreds of problems that I've clicked through on there. So it can be helpful to just kind of like know what the percentage is according to what k value they're talking about, and vice versa. So if you want to just like jot these down in your notes, this will kind of save you a step of having to do the 1 minus 1 over k squared each time. So when k is 2, you want to associate that with the phrase at least 75%. Okay, we saw that when k is 3, that correlates to the 88.89%. And then when k is 4, that's going to be the value 93.75%. And when k is 5, that's going to be 96%. So you don't have to, write those down or memorize them. You can figure them out for each one of these questions that you do. But it can be helpful to just kind of know that, like, all right, if I see this phrase, that tells me that k is 2. Or if I see that number, that tells me, k is 4, or k is 5. So let's actually do an example so you guys can see like how this theorem actually applies to some stuff. Okay, so example 7 says that the mean price of houses in a certain neighborhood is $50,000 and the standard deviation is 10,000. Find the price range for which at least 75% of the houses will sell. Okay, so we're looking for a range of values, and we see like a key phrase in here, and it says at least 75%. Okay, that's your key word there. So for at least 75%, you want to know that what the k value is that goes with that. Okay, so that's why I kind of showed you that little cheat box on the previous slide. So for 75%, that tells us that k is equal to 2. So to find that range of values, all you have to do is just figure out what mu minus 2 sigma is and mu plus 2 sigma. So you'll notice I'm getting the 2 here because k was 2. If k had been 3, it would have been 3s. If k had been 4, it would have been 4s, and so on. Okay, so mu is the mean. So the mean price was 50,000. So we'll calculate 50,000 minus 2 times sigma. Remember, sigma is the standard deviation, which they said was 10,000. So we have 50,000 minus 2 times 10,000. That's going to be the lower value. And then that'll go up to the upper value, which is 50,000 plus 2 times 10,000. So 50,000 minus 20,000 is 30,000. 50,000 plus 20,000 is 70,000. So that tells us that the price range for which at least 75% of the houses will sell will range from $30,000 to $70,000. Okay, now we can also use Chebyshev's theorem to find a minimum percentage of data values that fall between any two given values. So basically now we're going to kind of go the opposite way with it. So we're going to know what the range is, and we're going to try to find what that minimum percent of data values actually is. So sometimes students get confused with like, okay, how do I recognize that this problem is asking me to do this process? Well, some key phrases that you'll see in most of these questions, it'll say like find the minimum percent of data values. That's for sure a key phrase for this. Or the other way the questions will kind of be phrased is it might say like at least what percentage of values, blah, blah, blah. So either one of those like key phrases tells you to do these 3 steps that I have outlined for us here. So as we go through this example, I'll go through those 3 steps. So example 8 says that a survey of local companies found that the mean amount of travel allowance for couriers was 25 cents per mile. The standard deviation was 2 cents. Using Chebyshev's theorem, find the minimum percentage of data values that will fall between 20 cents and 30 cents. Okay, so step 1 says that we should subtract the mean from the larger value. So the mean was 25 cents, and the larger value in that range was 30 cents. So we'll do 30 cents minus 25 cents, which of course comes out to be 5 cents. That's step 1. And then step 2, we want to divide the difference, which was what we just found, by the standard deviation. And that's going to tell us what K is. So K is equal to the number that we got from step 1 divided by the standard deviation, which they'll give you in the question. So for us, it was 0.02. So 0.05 divided by 0.02 comes out to be 2.5. So K is equal to 2.5. Step 3 is use Chebyshev's theorem to find the percentage. Okay, so his theorem is basically the 1 minus 1 over K squared. And now we know what K is, it's 2.5. So we'll just have to calculate what 1 minus 1 over 2.5 squared is. And, just use a calculator for that. And it should come out to be 0.84. So that tells us that at least 84% of the data values will fall between 20 cents and 30 cents.